Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. So I'm just going to get started on our set of questions for today's session. Okay, so question 1 asks, why does ice float on liquid water? So an easy way to kind of explain this is that water is less dense when it's in its solid form. And this is a good question because, like, if you notice a glass of water with ice cubes, they always kind of float to the top. So even though they are the same chemical formula, H2O, the fact that it's in its solid state changes the density of water, making it less dense than it is in liquid form. So let's see what the junior tutor said. Ice is actually water in solid phase. When water turns to solid, when energy is given off to its surroundings, its molecules are able to form more stable hydrogen bonds, locking them into positions. Because the molecules are not moving, they're not able to form as many hydrogen bonds with other water molecules. This leads to ice water molecules not being as close together as in the case of liquid water, thus reducing its density. Unlike most substances, water is less dense when in solid form. It is actually the most dense at 4 degrees Celsius. Because ice is less dense, then it stays on top of the denser water. Yep, so this solution is correct. Okay, so moving on to question 2. What is the formula for calculating the gauge pressure? So if we have the pressure of a total system, this is actually equal to the sum of the pressure from the gauge plus the atmospheric pressure. So in order to calculate for the gauge pressure, we just need to rearrange this equation. And you end up getting P total minus atmospheric pressure. Okay, so this is the formula for calculating the pressure in the gauge. So the junior tutor said, the total pressure slash absolute pressure is the sum of the gauge pressure and atmospheric pressure. So P total is equal to P gauge plus P ATM. Therefore, the gauge pressure is P gauge is equal to P total minus P ATM. Yep, so the solution is correct. On to question number 3. How do you calculate the pH of hydrochloric acid? So first, I like to show HCl when it is dissociated into its ions. So this is what happens when HCl is dissolved in like water. It fully dissociates to H+, or protons, and Cl-, which is the chlorine ion. Okay, so usually you'd want to make sure that your reaction is balanced. So if we look at both the product side and the reactant side, we have one hydrogen on both sides and one chlorine on both sides. So everything acts in a 1-to-1 ratio. So to calculate the pH of HCl, usually we are given the concentration of HCl. So this is given in a question, and if we look at our reaction, since everything is 1-to-1-to-1, the concentration of HCl is actually equal to the concentration of proton ions, which is also equal to the concentration of chlorine ions in the solution. So this is helpful for us because the formula for pH is equal to the negative log of the concentration of protons in solution. So as long as we know the concentration of hydrochloric acid, that can give us the concentration of protons, and then therefore we can calculate for pH. Okay, so that is our final equation. The junior tutor said, to calculate the pH of HCl, you need to know the concentration expressed in molarity. You will use the following equation to find the pH. pH is equal to negative log times the concentration of H+. The hydrogen ion concentration is the same as the concentration of the acid because HCl is a strong acid and dissociates as follows. HCl makes H plus Cl minus. Notice the 1-to-1 ratio of HCl and H plus. So they also gave some examples. So if you had a 1 molar HCl solution, this has a pH of 0. If you had a 0.1 molar HCl solution, this has a pH of 1. And lastly, a 0.01 molar HCl solution has a pH of 2. Yep, so this solution is correct. Okay, so on to question number 4, which asks, what is entropy? So entropy can also be denoted as S. And definition of entropy is that it is the measure of molecular disorder and also the randomness of the system. Okay, so I'll just add some other little points about entropy. If you had the entropy of a molecule, when you have larger and more complex molecules, they tend to have a greater or higher molecular entropy. Another thing about entropy is that when a reaction increases in entropy, so I can write this as if delta S increases, then this means this reaction was favorable and spontaneous. So for example, let's say we had a balloon. Let's say we had a red balloon. And inside balloon is all of the air that keeps it like inflated. So the air in the balloon has a very high pressure. So when we force the air into it, since it creates a more high pressure, the air really doesn't want to be compressed in such a small space. So the minute that I puncture a hole in the balloon, then all the air that is inside it escapes, and we can, relating it to like chemistry terms, let's say the gas molecules escaping. This occurs spontaneously. And the process of the gas escaping would be considered an increase in entropy, because before all the air was ordered and it was just inside the balloon, but the minute the hole was punctured, all the molecules are more disordered and they move around. So this increased the entropy of the reaction. So let's see what the junior tutor said. The second law of thermodynamics states that all processes in nature tend to occur only with an increase in entropy, and that the direction of change is always such as to lead to the increase in entropy. So when we consider the three states of matter, we can conclude that the entropy of a gas is much greater than the entropy of a liquid, which is greater than the entropy of a solid. Gases have the highest degree of randomness since the molecules move freely, while solids have the lowest entropy since the movement of molecules is restricted. The chemical and physical changes in a system results in the change of disorder of the system, which may be an increase in entropy. So delta S is equal or greater than 0, or a decrease in entropy when it's less than 0. So there are two conditions that affect the value of entropy. The first is the degree to which the movement of the atoms and molecules in the structure is restricted. So the less restricted this movement, the greater the entropy. Secondly, the mass of the atoms and molecules which are moving, the greater the mass, the larger the entropy. So for example, a gas expanding into a vacuum will increase in entropy due to the increase in volume, allowing a higher degree of molecular disorder. Yep, so this solution is correct. Okay, so on to question number 5. What is the definition of chemical energy? So chemical energy is defined as the energy derived from chemical systems. So it is associated with chemical bonds and also intermolecular attractions. So an example of chemical energy would be like burning wood to make a fire. Okay, so the junior tutor said, energy is defined as the capacity to work or to produce heat. This can be classified into either potential energy or kinetic energy. Potential energy is the energy due to position or composition, and kinetic energy, on the other hand, is the energy of an object due to its motion. To illustrate the difference between the two, imagine a boulder on top of a hill. While the boulder is at the top and not moving, it would have potential energy but no kinetic energy. When the boulder starts rolling down the hill, it will gain kinetic energy and lose potential energy. So chemical energy is thus the energy derived from chemical systems instead of mechanical systems like the boulder example. Chemical energy would be found in the process of burning wood to make fire. Chemical reactions are also where one will find chemical energy. It is the energy associated with chemical bonds and intermolecular attractions. Yep, so the solution is correct. Question 6 asks, how do you calculate concentration from pH? So the pH equation is pH is equal to negative log of H plus. So if we are given the pH of a solution, then we're able to calculate the concentration of H plus, and then we can calculate the concentration of the solution that we started with. So let's have an example. If we had a solution of sulfuric acid, this dissociates into its ions, H plus sulfate ion, anion. So notice that in the balanced equation, since there are 2 hydrogens in sulfuric acid, 1 mole of sulfuric acid will produce 2 moles of H plus ions. So let's say the solution was given to us. So if the solution of H2SO4 has a pH of, let's say, 1, what was the initial concentration? So the first thing we have to do is plug in the value of 1 as our pH, and this is equal to negative log of the concentration of the protons in the solution. And now we just have to solve for H plus. So in order to get rid of the log, we are going to do 10 to the power of negative pH. Okay, so if we plug this in as 1, then we get an H plus concentration of 0.1 molar. Okay, so now that we know the concentration of H+, we can find the initial concentration of sulfuric acid. So I'm just going to rewrite this up here. Equal to 0.1 moles per liter. So this is why it's important to balance your chemical reaction, because we can recall that 1 mole of H2SO4 produced 2 moles of H+. So if we divide the concentration of H+ by 2, this can give us the moles, or the concentration of H2SO4. Which is 0.05 molar. Okay, so the junior tutor said the pH is given by the formula. pH is equal to negative log of the concentration of H+. Therefore, the concentration of protons is equal to 10 to the power of negative pH. Suppose we need to find the concentration of pH is equal to 1, solution of HCl. Substitute pH equals 1 in the above formula to get the H+ concentration. Okay, so they got that, and then the concentration of HCl is equal to the concentration of H+, because each mole of HCl on dissociation gives 1 mole of H+. Yep, so suppose we need to find the formula of pH is equal to 1 solution of H2SO4. Substitute pH equals 1 in the above formula to get the H+ concentration. So this is the same as what we did. The concentration of H2SO4 is equal to the concentration of protons divided by 2, because each mole of H2SO4 on dissociation gives 2 moles of H+. And they also got 0.05 molar sulfuric acid solution. So this solution is correct. Okay, so question 7 asks, is water an organic compound or inorganic compound? So water is an example of an inorganic compound. And this is purely because it doesn't contain any carbon atoms. So some examples of organic compounds would be like methane, or pretty much anything containing a carbon, even like a benzene ring. Yeah, pretty straightforward answer. Junior tutor said water is an inorganic compound. Organic compounds are any chemical compounds that contain a carbon atom. Since water has no carbon atom, it is an inorganic compound. Yes, so this solution is correct. Okay, so question 8 just asks, what are the units of molar mass? So the units of molar mass are grams per mole. So molar mass values can be found on their periodic table. And the junior tutor said, the molar mass of a molecule is defined as the mass of a molecule in a mole. The unit for molar mass is given by molar mass is equal to grams over moles. For example, given that you have a sodium atom, Na, its molar mass is 22.99 grams per mole. So this solution is correct. Okay, so question 9 asks, what is the organic product of the reaction below? Okay, so here we have acetaldehyde. And notice that it reacts with NaBD4, which is sodium borodeuteride, H3O+. So this compound is the deuterated version of NaBH4, which is a reducing agent. Deuterated. So typically, when you reduce an aldehyde, this turns it into an alcohol. So our final product typically looks like this. Notice the aldehyde becomes reduced and becomes an alcohol. This question had a deuterated version of NaBH4. So I'm also just going to write our answer instead of OH using OD. So when you have a deuterated molecule, this is considered like a heavier hydrogen because it has an atomic mass of 2, I believe. So it has an extra proton in there. So sometimes people use it to tag certain things, but won't get into too much detail about that. Okay, so acetaldehyde reacts with sodium borodeuteride to form ethanol. Yeah, so I'll just say the solution is correct, and then I'll just add a note about how the ethanol could also be the deuterated form as well. Okay, so on to question number 10. So it just asks to write electron configurations for the following cations and anions. Okay, so first I'll just write out the definition of electron configuration. So electron configuration is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. Okay, so this is a multi-step kind of question. So I'm also going to write out all the different steps on how we would calculate electron configuration. So the first thing is to divide the periodic table into atomic orbital sections. So I'm going to look this up on Google just to show what it would look like if we were to divide it into atomic orbital sections. So I'll just search periodic table, SPDF. Okay, so when we divide it into its sections, you kind of get 4 sections that look like this. The blue corresponds to the s orbital, or the s block. The green corresponds to the p block. The orange is the d block, and the bottom 2 rows is the f block. So the second step is to move left to right across the rows, starting at H. So when we write down the electron configuration, we first write the row number, then the block letter. Then another thing I'd like to note is that when you get to the D block and you need to write down the row number, you actually write down the row number -1. And similarly for the F block, you write the row number -2. Okay, so let's look at the ions that they want us to solve for. So first, part A. Sr, cesium, indium, and lead. So I like to first write down the electron configurations of the neutral atom, and then just to see what its electron configuration is. And then depending on the charge, whether or not it's positive or negative, then I can adjust my electron configuration as needed. So let's find our first element. So strontium is found all the way here. So I'm going to write the long electron configuration just for the first example, just so we can see how to do it. So moving left to right across the rows, starting at hydrogen, I'm going to write 1s and then 2. So the 2 means it has both, it stands for both the hydrogen and the helium. And then going to our next row, 2s2. So this brings us to beryllium. And then hopping on over, 2p6. and then 3s2, 3p6, 4s2, and then 3d10. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 4p6. And then lastly, 5s2 gives us the electron configuration of the neutral atom of strontium. So the question asks for the electron configuration of the 2+ ion. So when we have 2+, this means that the electrons were removed since electrons have a -1 charge. So basically, we just need to take out the last 2 electrons. So now its electron configuration changes, and we actually get the same electron configuration as krypton. So I'm just going to write it like this. Okay, so let's look at the next example. But this time I'm going to write the short hand notation for electron configuration, just so that we can save some time. So we just find cesium on the periodic table. You'll find it here, atomic number 55. And when we write the shorthand configuration, we look at the noble gas that comes before it. So before it is the xenon. And then we just continue the electron configuration like the same way that we normally do. So in this case, it's xenon and then 6s1. Okay, so now the question asks for cesium +1. So again, we just have to remove this last electron, and it has an electron configuration that is the same as xenon. Okay, so let's do the last 2. Indium is found over here, so atomic number 49. So its shorthand electron configuration is krypton, 5s2, 4d10, and then 5p1. Okay, so again, if we were to remove an electron, then this would be the following electron configuration: 5s2, 4d10. And then for lead, lead is found over here, atomic number 82. So its electron configuration is xenon, 6s2, 4f14, because we need to take into account the last 2 rows as well. So they are inserted kind of where this red line is. So 4f14, 5d10, and then 6p2. Okay, so when we have lead 2+, we take away the last 2 electrons. And then we get the following. Okay, so for part B, it's pretty much the same thing. except now we have anions. So this time, electrons are added. So instead of removing them, we add either 3 minus, 2 minus, or Br minus. So let's just quickly do these ones. A neutral atom of phosphorus has an electron configuration of, let me just write these down. So we can find it here. So phosphorus is at atomic number 15. And then if we were to add 3 electrons, we actually get the same electron configuration as argon. So all I need to write is argon in square brackets. For sulfur, it is found here. It has a 2 minus charge, so I'm going to add 2 electrons, and it is also the same electron configuration as argon. Then lastly, we have bromine, which is here, atomic number 35. And when you add another electron, it has an electron configuration that is equal to krypton. Okay, so now we can see what our junior tutor said. In writing the electron configuration of an element, we follow the Aufbau principle shown below, which states that the order of energy will dictate the order in which electrons are arranged in its orbitals. Therefore, the lowest energy will be occupied by electrons first. So another method of writing the electron configurations is to kind of write them in increasing numerical order. So they start with the S and they go up to 7, and then they align with 2p going up to 7, and then 3 going down to 6, and then 4, 5f. Remember that each orbital can hold a different number of electrons. S orbital can hold a max of 2, the p can hold a maximum of 6, d orbital holds a max of 10, and then f holds a max of 14. So an atom of strontium has an electron configuration. So they wrote the long version for the first one as well. Cesium has an electron configuration. So again, this is the long version, but it would still be the same. It just kind of gets like confusing to read. But basically, this looks correct. Indium 4d10. Yep, so that's what I got as well. And then lead 6s2, 4f14, 5d10. For the anions, an atom of phosphorus. So for phosphorus 3 minus, more electrons must be added to its subshell. The final electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6. So this is the same as argon. Sulfur has the same electron configuration, equal to argon. And lastly, the bromine with a -1 charge has the same electron configuration as krypton. So I can say that this solution is correct. Okay, so question 11 is another electron configuration question, and it's asking the electron configuration of nickel 2+. Okay, so first I'm going to write out the electron configuration of just a neutral nickel atom. So I'll do the long configuration. So nickel is found here, atomic number 28. And starting from hydrogen, we're going to move left to right, and then we're going to write out the row number and then the block letter, and then the corresponding electrons. So starting from hydrogen, it is 1s2, then 2s2, 2p6, 3s2, 4s2, and then 3d8. So when we have a nickel that has a 2 plus, notice how when we look at the electron configuration of a neutral nickel atom, it ends off with 4s2, 3d8. So if we were to remove 2 electrons, it's actually easier to remove the 2 electrons in the s orbital. So I'm going to say that since partially filled orbitals are more stable, partially filled d orbitals, I'll say. More stable. So instead of taking from the d orbital and making it 3d6, we're actually going to take from the 4s2. So this ends up giving us an electron configuration of 1s2, 2s2, 2p6, 3s2, and then 3d8. Okay, so let's see what the junior tutor said. Nickel has an atomic number of 28, meaning it has 28 electrons. But the nickel ion, Ni plus 2, due to the plus 2 charge, meaning it has lost 2 electrons. The electron configuration of nickel ion is short 2 electrons of nickel. For a neutral nickel atom, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. So the electron configuration of nickel ion is 1s2, 2s2, 2p6, 3s2, 3p6, 3d8. Yep, so that is correct. I think I just forgot the 3p6 in my answer, actually. I'm just going to fit that in here. So it takes a lot of practice. Oh, let me just rewrite this whole thing. So 3s2, 3p6, 4s2, 3d8. So I was just missing the 3p6. But right today. Yeah, but the more you practice writing electron configurations, the easier it gets because they all just follow the same pattern. So this solution is correct. Okay, so on to question number 12. What is the molar mass of laughing gas N2O? So they give us the the formula, the chemical formula of laughing gas already, so we don't have to look anything up. But basically, to find the molar mass of this compound, we need both the atomic masses of nitrogen and oxygen. So these values are just found on your periodic table. So for this compound in particular, its molar mass will be equal to 2 times the molar mass of nitrogen plus the molar mass of oxygen. And we multiply this by 2 since there are 2 atoms of nitrogen in the compound. So again, on the periodic table, you'll find that the atomic mass of nitrogen is 14.01 grams per mole, and the atomic mass of oxygen is 15.99 grams per mole. So adding these values up, we get a total of 44.01 grams per mole. So the junior tutor said 44.013 grams per mole. Explanation: laughing gas, N2O. Molar mass of nitrogen is 14.007 multiplied by 2. And then the oxygen, 15.99 multiplied by 1. Adding them up gives us 44.013 grams per mole. Yep, so this solution is correct. Question 13 asks, how many grams of NaCl is equal to a mole of NaCl? Okay, so first we need to bring up our mole equation, which is number of moles is equal to mass over molar mass. So to answer this question, we would first need the molar mass of sodium chloride. So the molar mass of sodium chloride is equal to the sum of the atomic masses of sodium and chlorine. So since there is only one atom of each, then we don't need to multiply by any whole numbers. So on the periodic table, we'll find that the molar mass of sodium is 22.99 grams per mole, and the molar mass of chlorine is 35.45 grams per mole. Adding these values up gives us a molar mass of around 58.44 grams per mole. So the second part of this question is to use the number of moles equation. So how many grams of NaCl is equal to a mole of NaCl? So we know that the number of moles is equal to 1, and we know the molar mass of NaCl is equal to 58.44 grams per mole. So we just have to rearrange the first equation and then solve for the unknown. So mass is equal to N times N, capital M. And then we just plug in our values. And our units for moles will cancel out. And multiplying 1 times any number just gives you the same number. So our answer is just 58.44 grams. So the junior tutor said, to answer this question, we use the formula number of moles is equal to mass over molar mass. In definition, the molar mass is the mass of a given chemical element or chemical compound in grams divided by the amount of substance in moles. So, yep, so in grams per mole. 1 mole of each. So atomic mass of sodium 22.99, chlorine 35.45. So they also got 58.44. And their final answer was also 58.44 grams of sodium chloride in 1 mole. Yep, so this solution is correct. Question 14. This asks, how many quarts are in 1 gallon? Okay, so there are in fact 4 quarts in 1 gallon. And the junior tutor said the same thing. So this solution is correct. Okay, so those are all the questions that we have for today's session. And if you like today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you'd like to submit a question of your own, then check out the links in the description. And also, if you enjoyed today's video, go ahead and give it a thumbs up and a comment. And don't forget to share with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.